Hey everyone, welcome to the science class for today. Today we're going to be working on gases. In the past couple of lessons we've been looking at solids, liquids and gases, and today we're going to be focusing on gas and the containment of it. Can anyone remember what kinds of gases that we're surrounded by every day?
Oxygen.
Yep, great.
Carbon dioxide.
Yeah.
Carbon monoxide.
Yeah, do you know what that comes from?
Carbon monoxide.
Yeah.
From exhaust fumes.
Good work.
Thank you.
And do you think gases take up space? Like when we think about oxygen, for example, we look around us, we're walking through oxygen, it's all around us, I can move my hands through it. Do you think it's taking up any space?
Yeah.
Yep.
Yeah, why do you think it's taking up space?
Because when you breathe in, your lungs expand, so they fill up with it.
Very good. What are some gases that can be contained? Do you know of any?
LPG.
Yeah, what does LPG come in?
Cylinders.
Good.
Oxygen
Yeah, and what can we contain oxygen in?
in a cylinder.
Yep. And if we think about breathing in and holding our breath, like, are we containing any gases there?
Yeah.
Yep.
Yep. Yeah, we are. What are we containing?
Oxygen and carbon dioxide.
Yeah, great work. So today we're going to look at, we're going to do a little experiment called gassy cola. And what we're going to be working with is the carbon dioxide from the cola and the pop rocks, and we're going to see what happens when we put them together. So first of all, we're going to start with our cola. We have a balloon here. We've just got to fill up the balloon with our pop rocks. Alright, we're going to break the lid of the cola. So as you could hear, it made that sound over the top of the Coke bottle. So the Pop Rocks hasn't yet touched the cola. What do you think is going to happen when the Pop Rocks reaches the cola?
It'll bubble up.
Bubble up, yeah. Any other ideas?
Yeah.
What do you think? Yeah, it could do that. Alright, so...
Blow up the balloon.
Oh, we might. We'll soon find out. So we're going to add the Pop Rocks to the cola. And we'll see what happens to the balloon. So you can see it fizzling. And the balloon is slowly getting bigger. So we'll just leave that there for a moment. So what's actually happening is the popping candy itself has a shell around it, and it's kind of it's trapped carbon dioxide. So when that shell gets wet from either your saliva in your mouth or, for this instance, the cola, it makes that crackling sound. So when the carbon dioxide from the popping candy meets the carbon dioxide in the cola, which is usually trapped by the sugar and water formed into the bubbles that you see, it creates a chemical reaction, and the carbon dioxide rises to the top and pushes the balloon up. And that's what's making the balloon rise. So I'll just put that to the side. So if we were to do this experiment as a fair test, and we were to do it as a class next lesson, what's some modifications that we could do to create this experiment again, and then by the end of it the class can compare their results? Any ideas?
Change the soft drink that we use.
Yep, so we could use all different soft drinks. Each group would have a different one. We could see if it's only cola that does this with the popping candy, or if it's any cool drink.
maybe different brands of popping candy.
Yeah, that's right. I'm sure they've got similar ingredients, but they could have different ingredients in them. Just like any chocolate bar, they've got all chocolate's chocolate, but they've still got the different ingredients to make it taste different. So yeah, we could try different brands of popping candy. Any other ideas?
How much of the soft drink we use?
Yeah, that would be interesting. Seeing if the amount of cola makes the balloon go bigger, and how quick we could put a timer on that as well. So we'll have a bit more of a discussion about that and see how we go with coming up as a group for a modification to do it next week for ourselves. Thanks.